Hello everyone, my name is Nicholas. I'm a serverless specialist solution architect working at AWS. And today I'm going to talk to you around the relationship between developers, operators in a serverless world. So more specifically, the promise of DevOps and how does it relate to a serverless application. So for today's agenda, I'll start a bit with a short history of the relationship between Dev and Ops. Where do we come from to kind of set the scene. DevOps has many meanings for many different people, so I always think it's a good idea to start just to put a bit of context here. And then how has the role of operations changed in a serverless world? Then we'll go into talking a bit more about the relationship between builders and operators and how they can work together through some concrete examples. So first up, where do we come from? What's the history between, on the relationship between developers and operators over time? And for this, the way I like to see it is from the developer side, you have this aspect of always wanting to keep moving forward, right? So building new features, building new applications, building new capabilities. But from the operational side, you have this idea that you need to keep the lights on. So okay, there's deploying the new application in production, but then making sure that these applications are reliable, that they're going to stay online, stay working in the way they're expected. So that's kind of this maintenance of the infrastructure aspect. And if they don't meet that objective, so from the developer side, you have a risk of being out-innovated, right? Building new features is just because there's always an opportunity to improve the product. There's always customer feedback, new things they'd like to see. And if we stop all development, thinking about worst case scenario, if we stop all development, that's opening the door for someone else to come and bring these innovations that customer wants. On the other side, from the operational perspective, if we don't keep the lights on, if we don't make the efforts to maintain that infrastructure, we risk downtime. We risk having our application not being available. But both of these have the same final consequence, which is the risk of losing business, right? But so that's kind of the thing, that even though these two needs are very much against each other, right? Every change you add to your application, every new feature that you build, have a risk towards the existing environment, have a risk of causing downtime in the existing environment, because what's in production is stable and works, but if you add a new change, well, this could cause instability, this could cause performance issues and so on. So it's always a very hard balance between the two. And if you think a bit about how dev and ops, in a non-DevOps world, kind of think of each other. You have the devs on one side saying, yeah, I built that new feature, it works on my machine. And when I build a new feature, I just want it to go to production, but the ops team, they take ages to put anything in production. And when I have a feature that works on my machine and so on, I might have people from the ops team asking me to make changes, making updates for dependencies because there are vulnerabilities, making configuration change because this might pose a security risk or because that causes issues in some system in production and so on, right? But these are not related to my system, which works on my machine, right? Why don't you just put it in there? And from the ops side of things, well, we'll have developers saying, hey, the change that you made, it looks great, but we've tried into a pre-prod environment and it doesn't work, right? We tried on staging, it doesn't work. And when we report these bugs, dev might take ages to write fixes. They're always going to prioritize the new features instead of just making the current system work effectively. And finally, just keep telling us to deploy things, but we see it from our side, it doesn't work, right? There's these issues, there's these bugs and so on that needs to be fixed because our objective is reliability. And we see quite well here how these two roles kind of conflict with each other. Devs want to build new features, ops want things to work. And it's not always easy to balance the two. And that's kind of where the idea of DevOps comes from, right? Is to have dev and ops working together. And so instead of having the one side, the developers just throwing things on the other team, the idea is to work together on multiple steps. So if we look at this schema here, starting with the plans phase in the middle, well, planning is something that has to be done by both sides. Right? It's not just planning new features, but it's understanding does this new feature has an impact on production environment. Does it require new hardware? Does it require, does it have a performance implication and so on? Is it going to cost more as well to run? So these are the kind of thing where working in tandem is very important. Then dev will build the new features and so on, code it, write the test to make sure it's working. And then comes the time to release it. And then we go back to working together, kind of the release cycle here. So often in DevOps, you will hear about CI/CD pipeline, automating that, which is really much about working together. And in the serverless work, we have infrastructure as code, where devs will own part of the defining the infrastructure that's going to be used to deploy it. And then so we deploy the workload, for example, using CI/CD pipeline. Then we have all the operational aspects, right? So it's monitoring key metrics, monitoring performance, error rates, and these kind of things. And then based on that, there might be feedback, and that needs to be incorporated back into the planning phase. It's kind of a cycle, because maybe we want to build a new feature, but there are lots of bugs, or there's a critical bug in the system right now that needs to be taken care of. It is really important to be able to prioritize these two aspects in the best way possible, so that we can keep moving forward, but we don't forget the bugs or the issues that we might have, or the performance issues and so on, right? So what does it mean in practice? Well, it means that the planning phase, as I was mentioning, is about around building these new features and these new applications should be done together, hand in hand between dev and ops. One important aspect as well is to automate as much as possible, the testing, the deployment, so on, so that we have repeatable systems. And you might also have developers on call, right? Because the developers are the one that's built that application. So it might be important for them if, of course, we're not talking about bugs every half hour or something like this, but if there is an emergency, that developers should be able to be involved as well, because they know the code, so they might know what needs to be fixed there. And in terms of the collaboration, in terms of the deployment, I was already mentioning the aspect of infrastructure as code, so that developers and operators can work together to define the infrastructure that's needed for that workload. So not just the code, as we typically traditionally do, but also the resources that's where the code will run on. But just one remark, there's of course lots of practices that you can do, but there's no strict DevOps rules, especially because it depends a lot on the culture that you might have within your company. Where are you in your cloud journey, and what are your needs for that specific application? If we talk about regulated applications, well, you might only be able to do a deployment every 3 months, for example, maybe for some regulations. Or on the other hand, maybe you want to actually do multiple deployments a day. And that will have lots of impact in terms of how you actually model the practices between developers and operators. But then you also have the serverless-first strategy, right? Because DevOps is not something that's specific to serverless. And so the idea of a serverless-first strategy is that you build, the modern applications are built serverless-first. So it's a strategy that's going to prioritize the adoption of serverless services first, so that you can increase the agility throughout the application stack. So basically the operational management required to run and scale the applications is handled for you by the cloud platform. And the key benefit of that is that you can go to market faster, innovate more. So there's less boilerplate, there's less on the operational burden. There's more of these things are handled by the cloud platform, so that you can actually build these new features and a new application faster. And so just to show you a bit, what our customers are thinking about that, here are 2 quotes, which I think showcase a bit well, what are the benefits of having a serverless-first strategy. So on one side, so for Edmunds, have this quote here: "What took us just a few days to build using a serverless solution based on AWS Lambda would have taken us 6 months to build from scratch." Right? And that's the benefit of having these building blocks that already take care of lots of the infrastructure management, configuration, and so on. And you can just focus much more onto your business logic and your differentiator. And on the other side, from Neil or Austin from Alma Media, the main thing is developing new and better services for our customers. We don't really have people maintaining servers. We don't think that that is our objective. But that actually brings a question. I mentioned the aspect of operation, the idea of not maintaining server, and you might have heard of the idea of no ops, right? So does serverless means that you don't need op? Well, no, not really, because operations is much more than just managing servers. And so now let's go a bit into the role of operations in a serverless context. And so first of all, the operational responsibility. So what are the responsibilities of operators when you are running serverless workloads? Well, we mentioned that, we don't have the servers to manage anymore, but operation is not just that, right? It's also about allowing, as part of the release deploy cycle, allowing faster and safer deployments of new features. So having a strong CI/CD pipeline, having automated tests, and helping developers actually implement all those. So that this way they can build, experiment, and so on. And one thing I found really great with serverless is that every developer could have a replica of the production environment so that they can all test on the cloud, on actual cloud resources, their new features. So not just testing the code, but actually testing the integration, the configuration, the permission, security, and so on. Then another aspect of that is also creating tools to improve the developers' lives. So if you have common patterns, if you have standards, let's say on security and so on, you can incorporate that into tools so that you improve the developer's life. They can go even quicker to build new features and make sure that they respect the guidelines that were set on the operational side. And then there's, of course, all the things around optimizing the performance, fine-tuning, and so on. So if you think about a service like AWS Lambda, where you might tweak the memory setting, which will also give you more CPU, more network resources, and so on. And then being part of the feedback loop for improving the reliability of applications, right? If there is a bug, if there are issues, and so on, it's a key part to make sure that this gets escalated back to developers and that this gets prioritized accordingly. And so if you want to look a bit for inspiration, and if you haven't done so already, I highly advise you to read the Well-Architected Frameworks. It's a series of best practices. And there's lots of good things there on the operational side and on the role of operators. And so that actually leads us a bit into the builders and operators side of things. And I want to really make sure that because before I was talking about dev and ops, but I believe there's an important distinction to make here. And I want to change a bit the semantic between dev and ops to builders and operators. So the first thing here, if we go back to the idea of definitions, that the builder's role is to build new solution. And the operator's role is to focus on the deployment safety and speed. So allowing the builders that's building these new solutions, new features, new applications, and so on, to deploy safely into production, and as fast as possible to reduce the time to market. But from the operator side, that means that it comes with creating internal tools, setting up automated pipelines, maybe things like pipeline vending machines, so allowing builders to just provision pipelines by themselves, creating best practices, guardrails, and guidelines, of course, for the builders to follow. And then on the builder side, and that's really important in serverless, is the ownership of the end-to-end architecture. So not just the code, but also the different components. If you think about a serverless architecture, you have the API, you have the compute, the database, and so on. So the builders take ownership of the entire end-to-end architecture. That means that they will also configure the components through infrastructure as code. So if you think about a classical model where you might use EC2 instances, for example, you might have a model where the developers just write the code that are going to be run on EC2 instance, but the rest, so the instance, load balancer, database, and so on, might be handled by the operators. But here you have actually a bit of a shift, because the builders on the end-to-end architecture. So with all these components and the configuration and so on. And of course, it's important for the builders to fix these bugs that might occur, but at all levels. So not just the code, but if you have issues with security policies, if you have configuration issues between services, because we use infrastructure as code, that also becomes the builder's concern. And what this means is that there are ops tasks in the builder's team, and there are also dev tasks in the operators teams. So from the operator side, you have creating these tools to help the developers, but that requires a bit of development effort. And from the builder's perspective, because you have this end-to-end ownership of the entire stack, that means that there is a need to understand a bit more about how this works and so on. So there might be some operational tasks. That's kind of why I want to move away from dev and ops and to talk about builders and operators here. And so if we look at the builder's perspective, well, in a serverless-first strategy, the idea is that builders can leverage all the AWS services to build serverless applications. So they are free to choose the right tools, they're free to choose what works best for their workload. So you might want to use API gateway for REST API, or you might want to offer GraphQL API. And in terms of database, you might choose DynamoDB, you might choose something else, and so on, right? It's the idea that you are free to make the right choice based on the requirements that you have. Then from the operator's perspective, well, the operators are then going to define the best practices and guardrails to maximize the freedom for the builders, but also making sure that everything is going to be configured, that you don't have something that's just open to the internet, right? And the key idea here is, of course, creating guardrails that are going to limit builders, but also creating tools to facilitate best practices adoption. To make sure that, for example, having templates, having a CI/CD pipeline that do this kind of check to make sure that the builders can confidently build something and know that there's going to be help along the way to build fast new features and application without having to always go back to the operators and so on. And so how do they work together now, these builders and operators? And for this, I think it's interesting to look at how the builders interact with the AWS platform. So in the model I was mentioning before with EC2 instances, developers might just touch the code that's run on EC2 instance. So they have a very limited interaction. But here we're talking about end-to-end ownership for the builders, right? So I've seen that there's kind of two ways of doing that I like to call fenced path and paved path. With the fenced path approach, it's a bit stricter in terms of guardrails, so you might have one way to do it. And that's great because there are fewer chances for mistakes. So that's easier to onboard a newer developer, more junior developer. And it favors a kind of convention of a configuration approach. So this way there are standards that are well established. There's one way we do things. It's already more limiting, but it's also much easier for new developer because you have less chance of mistake. On the other side, you have the paved path approach, where there we basically give more freedom to the builders to use the right tools for the job. So we might provide standard templates for common patterns, but the idea there is that the builders are free to configure however they want. So it's more of a configuration of a convention approach. But that said, it's not just one or the other. I think they are more of a spectrum between the two. And what will change there is that if you look at a fenced path approach, well, the operators will usually take more responsibility because they will define strict guardrails and one way to do things. So they take more ownership in terms of making sure that the tools can actually provide the builders and will allow them to do everything they want to do. It also means that you lose in terms of flexibility. So if you think about, for example, allowing AWS services only after they are vetted by the operators or the security team, well, this means that the builders will have less choice in terms of which AWS service they might use, and so on. On the other side, of course, if you go with a paved path approach, well, there's less responsibility for the operators, but we gain on flexibility. On the other side, with a fenced path approach, the learning curve is just shorter for builders, right? Because there's one way to do it. You don't necessarily need to learn about lots of different AWS services. And for the builder's perspective, a fence path approach has less responsibility, but you lose, and the key aspect here is the flexibility. That's going to be very important over time as people take more and more ownership. And for serverless-first strategy, I'd say that the end goal is to go towards the paved path approach as much as possible, to really enable the builders to make the right decisions there. But that said, it's okay to start a bit earlier in the curve, to start a bit more on the fence path side, because this is something that can evolve over time, right? You can start somewhere based on where you are in your cloud journey today, and then over time, as builders gain in confidence, as you build the confidence, best practices, and so on, to move slowly toward the paved path approach. So how does it look like in practice? And so for this, I just want to start with a sample structure that you might have for AWS account. So let's say that you have a team, there's like a builders team here on the left that want to create an application that's going to run into its own AWS account to be isolated for other teams. Well, then the operators team would provision a set of accounts for these resources. So there might be, of course, the production account, that's kind of our own goal. There might be a staging account, that's a replica of our production environment. And then a playground account where builders have full access to experiment with the AWS platform. Then on the operational side of things, you will have the CI/CD pipeline, so probably in a separate account as well, that will deploy to both staging and production. And then just an account that I always recommend to have separate for logs, backups, and so on, so that even if something goes really wrong, you still have something that's isolated where the builders team only has read access there. And so the operators will manage the CI/CD pipeline, will oversee the logs, backups, and so on. And from the builder's perspective, well, they have this playground account with full access, so they can experiment, try new things, test very fast, by actually deploying onto AWS. And then when they're happy with the new feature, they can then push the code through a repository that will trigger the CI/CD pipeline, and that will trigger the deployment, with automated tests and so on to staging, and then if everything goes well, to production. Then the builders also have access, read access to staging and prod to make sure everything is working fine, and also understanding quickly. So if they need to look at logs and so on, if something went wrong, and also read access to logs, backups if they need to restore something. And so zooming a bit into the CI/CD pipeline part now, here's what it can look like, where the builders from one side push some code, and here I'm using AWS specific services, but this is not exclusive to AWS services. You can do that with other tools for CI/CD pipeline. So code commit can be replaced by, it's a tool for managing repositories, but you can use another tool for this, for example. And so the builders would push a commit, do a pull request that would get approved and merged. That would trigger the pipeline with code build, actually building the functionalities. And then I've put in red here what's owned by the operators team. And the operators could enforce some security tests, making sure that if you use, for example, a service application, making sure that the code in Lambda function is up to date and secure, there's no vulnerable dependency, making sure that the IAM policies are strict and so on. And then when all these tests pass, we deploy into the staging environment using an IAM rule that's managed by the operators team. If we want, for example, to restrict to certain services, or we want to restrict to not allow to launch the largest EC2 instance, for example, right? Yeah, don't forget that a serverless-first approach is not just about a serverless workload. The idea is to start with serverless, but you might still have EC2 instance if it makes sense for your workload. And so from there, we go into our next step, which will be automated test. That could be owned by the builders team, right? Because they know their workload, they know what they need to test, and so they do this automated test here. And then from there, you can have a manual approval, or if you trust the test enough, then you could have also automated deployment into production using an IAM role that will mirror what you can do in staging to ensure that you have parity here. And so just to show you a bit of an example of guardrails that you can have in the CI/CD pipeline, So you could have something such as linting CloudFormation templates. So that means verifying if they are valid templates, if they're actually going to work. But you can have additional checks. I mentioned already checking the IAM permission, but you could enforce some things such as, if you use Python for your Lambda function, you can only use the newest version of Python or the newest version of Node.js. We will not allow older version, for example. Then we can audit the software dependencies for vulnerability. Maybe you have some restricted licenses, some open source license that you don't want to use and so on. And we have this aspect of running the automated test. And then finally, you could have manual automated approvals before deploying into production. And so that's the pipeline, but what does it look like into the staging or production environment? So as I mentioned earlier, I recommend that stage and prod actually look similar to each other enough so that if you deploy something to staging, if you do the test in the staging environment, well, then you have a pretty high certainty that the production environment would look the same and will operate in the same way. So here we have this CloudFormation stack to use infrastructure as code. That's going to be owned by the builders team, so they have the control. But once again, with the restriction that the operators team can put in place. But the operators have also other tools they can use to monitor that account and verify that we are, everything is within, is compliant with the guardrails that they've set. So there are tools such as AWS CloudTrail, AWS Security Hub, AWS Config, or Amazon GuardDuty that can be used there. And actually, to show you a bit of an example, let's say that you have a Lambda function that has too permissive, an IAM policy that's too permissive, or doesn't have the right, doesn't use the latest Python or Node.js version or something like this. Well, with AWS config, you could write a rule for this, and based on that rule, it could trigger an AWS Lambda function that could automatically remediate the issue. So let's say you want to use Python 3.8, this is using Python 3.7. You could have something that will automatically change the version to 3.8. But of course, changing a version could have some risks, right? Such as libraries not working the same ways and so on. You might not want to cause issues. So what you can do instead is then use something like Amazon SNS to send an alert to the builders to make sure that they are aware of that issue and that they should, remediate it. Now, if we're looking at another case, and now we're shifting a bit more towards the fenced path, we could have a scenario where the builders team, own their product account, production account with some features and so on, but maybe you have some strong compliance requirements on the API layer. And therefore, you want the operators team to actually own that, to make sure that the security policies and so on are enforced, so that some aspects there are enforced as they should be, to make sure we don't accidentally have something that's just open to the internet. So in that case, what you might have is actually that the operators would own an API account, which contains an API gateway, which use a Lambda authorizer, for example, with the right authorization mechanism for your workload. But behind the scene, what's behind it, that API gateway, the builders team can choose whatever they want there. But here you have a bit more control because what's actually exposed to the internet is now controlled by the operators team. So we are slightly closer to a fenced path approach. Now on the other side, you might actually have an even more lax approach, much more towards the paved path approach, where you might have some security baselines. So we mentioned earlier, CloudTrail, GuardDuty, AWS config, and so on, but just give entire freedom to the builders, even on the pipeline, right? So that even the builders even can decide what they want in their pipeline and so on. So they have complete freedom there. And the decider where you want that to be is, as I mentioned earlier, it's really about what you feel confident having, where you feel confident right now, where are you in your cloud journey, and that can evolve over time. And so to give another example here, you could have freedom for the builders to deploy things, but then the operators team would own an alerting system to make sure that the developer is actually aware of that, or that if you have third-party people actually taking care of a 24/7 maintenance on common tasks, for example, they get notified by that. So on the left side, we would have our workload, owned by the builders team, and they would still be responsible for creating CloudWatch alarms. So alarms based on the health of the workload. And then when an alarm is raised, you would have an SNS topic that's owned by the operator that will receive these alerts and then dispatch them correctly, based, for example, on the severity, right? So you might have high severity alerts, then we send a text message on mobile phone, or you might have a medium severity that we send through email, or we use a third-party system, for example, or you might have third-party companies and so on. But that's kind of the infrastructure on AWS, right? There is all this part about bringing workload into production, where the operator's role is key. I think so. And for me, it comes into reframing what do we mean by the definition of done. So when the builders build new features, there's of course this question of, does this new feature meet the user's need? Did we do customer research on this? Did we ask customer, do we have a good understanding that this new feature will actually be helpful for customers? But that's just one part of bringing a new feature into production or bringing a new application into production. There's all these other questions that are very important, such as, is it maintainable in the long term? Do we have proper documentation to make sure that we understand how it works, and that if we have a new team member, they'll be able to understand what's going on in there? How much does it cost to run? That's always a very tough question. And that's kind of where serverless can be interesting, where you can deploy it, you can run tests at scale to understand a bit what's the cost per user, what's the cost per query. And based on that, is it something that we can make profitable? Is it something that makes sense? You might have an idea for a great feature, but that might so far exceed, the cost of that new feature might be so expensive compared to the benefit that it might not be worthwhile, even though it might be something super easy for builders to implement. And then you also have questions on the reliability requirements. What's our SLA? How do we make sure that we meet them? What's our mechanism? If we fail or if we're at risk of not meeting them. So, I mean, for SLAs, we often talk about the nines of availability. But is it all? Are there other things here that we need to think about? And then on the other side, you also have the performance requirement. If you have an API, what should be our P99 latency, for example? How do we make sure that this is not taking too long? How do we make sure that we're not creating a negative experience by having users waiting for multiple seconds sometimes? And then on the security side, did we evaluate what's the threat model? Who are potential attackers? What are the security risks? What happens if some part of our system is compromised? And do we have a good understanding of this? Then serverless applications scale really well usually, but even then, there might be something that will break at scale. So that might be because you hit AWS account limits, or because you have some components that are not serverless in your workload, or you might depend on third-party APIs that have a limit in terms of number of API calls you can make. And if we have this risk, how can we mitigate that? Right? Do we need to create a buffer and so on? These are very important things to ask ourselves before we actually put something into production. And then finally, requirements change over time, and AWS will keep adding new features, new services, new way to do things. Is it easy to change our application? Right? Can we change the architecture? And sometimes we might need to change the architecture in widely different ways because there's just something so much different, or we realize that users actually using our application in a very different way. Can we do that? Is it, and within Amazon, we often talk about one-way door or two-way doors for these kind of things. And so to help on this kind of things, I mentioned a bit earlier the well-architected framework, and in the AWS console, there is a tool that really helps on these kind of things. So before you go into production, there is a tool in the AWS console called the well-architected tool, and there you might do some reviews. You have a series of questions, and you have also a lens just for serverless workloads And so you can go through these questions and so on to see like, hey, how are we doing? Are we following AWS best practices there? Do we have any high-risk issues? And if we have any high-risk issues, is it serious for us to take that back and go back to the drawing board or fix that before we go to production, or is it something we can do later? And that's something I found very valuable to do before you go into production, and then also to do it periodically with a new workload, to do, for example, every 6 months and so on, just to check how you've evolved. We mentioned earlier the difficulty of balancing between new features and fixing issues. And the well-architected framework really helps kind of set the expectations there and go back to this to make sure we understand where we stand. Then we have some tools that can help with best practices. So one of them being the AWS Lambda Power Tools, which is a series of libraries that are currently available for Python and Java that help with create structured logging, helping you with implementing traces for distributed applications, and also creating custom metrics, such as business relevant metrics, or because you might have better proxy for the health of your application than just error rate or something like this. And so, just as a quick recap onto the builders and operators. So on the builder side, we saw that it's not just about development, it's about the full stack ownership, having the freedom also to choose the right tools. And this key idea is to focus on building new solutions. And then on the operator side, of course, it's sometimes creating tools to help the builders, with the key idea at the end is to really be focused on deployment safety and speed, so that the builders can do their job of building new features, building new solutions and so on, but can do it safely and also with the shortest time to market as possible. And so with that, thank you very much. If you have any question after this, if you're watching this asynchronously and so on, don't hesitate to reach out. So you have my Twitter handle here. I'm also available on LinkedIn, so feel free to reach out. And thank you very much for listening in to this talk.